Hey there, and welcome back. So, now things are starting to get more advanced. We are moving our player with a joystick, we are loading our background graphics, our rooms. We have seen a lot of different things like that. But still, it's not really a game. Because we can load our rooms, we can load the backgrounds for our rooms. We have tile collisions, sure. But how do we know what enemies are in which room? And how do we know where to place them? Stuff like that. So, if we look at the game now, we have a spinning coin down here. I have an enemy here. If I go to the next room now, there's a guy here now. How did he know to spawn right here? So there is, we have two guys here. So how can we place those? How can we load some sort of information about the rooms? Well, that's what we're going to look at today. And this is a system that I just call room info. So information about the different rooms. So let's take a look at that. But before we look at that, let's go back to our Sprite library for a second. So here in my Sprite library, we have seen this handle sprites routine, where a lot of stuff is happening. But I have a subroutine here called createSprite. Now, this is what I was talking about a while back. I wasn't sure if I was going to call these things sprites or objects. If I had called them objects, then this would probably have had made more sense. Create a new object, right? But I've called them sprites, so let's just stick with that. So when I say create sprite here, what does that actually mean? Well, it means that we create a new object in our game. So this could be anything. It could be an enemy, it could be that little spinning coin, or maybe if this was a game where I was shooting something, then create sprite here could be when I push the fire button, I create a bullet that flies along. So this is just a system that's going to create a new object for us. So how does that work? Well, now we have to think of the bigger picture. Now I have said in my game, I'm gonna limit this game to the 8 sprites that we have available on the Commodore 64. So I've told you before, briefly told you before, that there is a technique called sprite multiplexing, where you can have more than 8 sprites on the screen at once. But that's an advanced technique, we're not going to be looking at that. So we have 8 sprites available. So and let's also take a look at another thing here. We have our sprite constants. Let's see there. We have our sprite constants. One of those is called sprite enable. That's memory address D1015. So in memory address D1015, that's just 1 byte, right? And we know that 1 byte, that's 8 bits. In this memory address, each of those bits tells us that a sprite is active or not. So if we look at an example file from the last episode, we see that here I'm using that memory address, D1015, the one for enabling sprites. And as you can see here, I set bit 0 to 1 because I want to activate sprite 0. Alright, well, as long as you understand that each of these bits can activate a sprite or not. So the thing I do in my Sprite library here in createSprite, I use that memory address to keep track of what sprites are active and what sprites are not. So let's take a look at this subroutine, createSprite. So first of all, I make sure to save my X and Y register on the stack, since we are going to be using those here. So I have something called createSprite loop in here. And just like before, I'm loading X with 0 to start this loop with 0. Then I say load this memory address, Sprite enable, that's D1015, right? Then I say and it with Sprite binary, comma X. Now Sprite binary, that's a table. So let's take a look at that table. That's in Sprite tables right here. So there is my Sprite binary table. So what this table is, it's just 8 bytes like this, but as you can see, for every byte here, it's just zeros, right? But there's a 1 in here. So for every byte we go down, the 1, as we go down, the number 1 goes to the left. So here we have 1 at the 0 place, here we have 1 at the 1 place, here we have 1 at bit 2 place, here's 1 at bit 3, and so on. So this is just a simple method that I've used to if I need to use a table and I need to make sure that I know where the bits are in relation to that table. So it's a little hard to explain, but if I load X with 0 now, then we get a 1 here. So we have a 1 at the bit 0 place. So maybe it's easier if I go back to Sprite Library now. If I say load Sprite enable, that memory address that keeps track of what sprites are active, and I say and it with Sprite binary, comma X. Now right now X is 0. So I'm loading that memory address and it with Sprite binary, comma X. So I'm ANDing it with Sprite binary, that's this, and this is 0 now, the 0 position. So basically I'm saying here in my Sprite library and with this number, right? Because that's the number that was in the first position in my Sprite binary table. So why do I do that? Well, when I do that, when I AND it, I can find out if there's a 0 or a 1. So let's say that let's say that it was let's say that it was there was a sprite active at position 0 in this memory address. This is memory address D1015. So I'm loading that memory address. So let's say that we know that the contents was this. All right. Maybe it's easier if I do it this way. So, all right, then I'm ANDing it with Sprite binary, comma X. Now X is 0 right now. All right, so I'm going to load this table with 0, X0, so that's this. All right. So I'm ANDing it with this. Now, we know that when we're using AND, we need to have 1 and 1 for it to become 1. 1 and 0, that's 0. 0 and 1, that's 0. 0 and 0, that's 0. So there has to be a 1 in both of these for it to be a 1, for the result to be a 1. So in this case, if Sprite enable was this now, all right, so there was, so Sprite 0 is active. Then I say AND it with this from my Sprite binary table. All right, then I say branch if equal. That means that if the result of this is 0, then I'm going to branch here. Now if we AND 1 and 1, that's a 1. That's not 0. All right, so we are not going to branch if equal because it's not 0. So we're not going to go here, then we go here. So hopefully that makes sense. And again, you can see that it's a good idea to be comfortable with the basics here, and, or, and stuff like that, how that works. So I'm ANDing these two together now. And if I load sprite enable and there was a 0 at the position that I'm ANDing with, then I say, so if this and this resulted in a 0, branch if equal empty sprite slot found. So basically what I'm doing here is I'm checking this memory address bit for bit using my sprite binary table here. Now the reason it's a good idea to use this table is because I can have a loop now, and I can use x0, 1, 2, 3, 4, 5, 6, 7. So just by increasing x and loading from this table, I can go through all of the bits like this. So that's what I'm doing here. I have a loop. It's gonna run through 8 times. Let's see if we can find the bottom here. Yeah, compare max number of sprites. So it's gonna run through 8 times. And I'm checking one bit after the other in this memory address. And I'm trying to find a result that is 0. Because I'm saying in my code now that if I find a bit in this memory address that is 0, well, I'm gonna say that that means that I have an empty sprite slot. So because if there's a 0 in this memory address, then that means that that sprite is not active. So this is a little complex, hard to explain, but hopefully it makes some kind of sense. We're just scanning through this memory address bit by bit to find an empty slot, an empty bit, or a bit 0. Because then I'm going to say that that's an empty slot, and I'll go down here. Now remember, let's say that I had to run through this loop 3 times, for example, to find a 0. So if, let's see here, maybe the first 3 sprites were active. Sprite 0, Sprite 1, Sprite 2. So when I ran through this the first time, it was a 1. So I jumped to check next sprite slot, which basically just goes down here and increases x and goes back up here again. And then sprite 2, that was also occupied, and bit 0, 1, and 2, all of those are occupied. But then I get to this one and I AND it with let's see, 0, 1, 2, 3. So I AND it with this because x is 3 now. So and 0, 1 and 0, that's yeah, I did the check. It's so hard to explain this because there's so much going on, but basically when I get to this point, I see that this is now going to result in a 0. Hopefully that makes sense. Anyway, this is just a way to check if I can find a free slot. Alright, well, now I found a free slot. So empty sprite slot found. Then I load sprite X here, but here it gets a little bit more complicated. Where is this sprite X? Well, now we are connecting my room library, but let's just come back to that in 1 minute now, and let's just continue to go through here. So basically I'm loading this sprite X thing, and I'm saying branch if not equal. So if this whatever is in here is something else than 0, then we're going to branch to create this sprite. If it's 0, then we say jump down, done create this sprite. And as you can see here, if sprite X position is 0, then skip create sprite. So that's what we have to come back to later. But anyway, let's just quickly go through this to see what's going on. Basically what this thing does, after doing the checks that we talked about, it stores the X and Y position of the sprite, and since we are using this loop with X, we know where to update those positions in those two tables. And then we have something here called load sprite type, and we have some new tables here. So like I said, there's a lot of stuff going on in here. So I think right now we need to take an overview to see what's actually going on. So it's a little hard to explain this because there's so much going on, and it's hard to know where I should start explaining because one thing is connected to the other thing and so on. But think of it this way. We have seen our room library. That library has a subroutine called load. That loads our room. We've seen that. So we can load a room, say let's load room number 2. So we load room number 2 and then we load this. Then we get the background graphics for room number 2. Now that's just part of the story. I also have something called room info that I just mentioned a while ago. What's that room info thing? Well, here we go. Here is my room info. My room info file is a huge file with tables. Basically what this is, I have a table for every single room. So in my game I have 64 rooms. Every single room has their own table like this. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 bytes in each of these tables. So what are these? Well, the first thing is something I call the room flags. Let's not worry about that right now. Second one is warp out room. Then we have warp in X, warp in Y. But then we get to here. Sprite 1, that's sprite type, sprite 1X, sprite 1Y. And we have the same thing for sprite 2 and sprite 3. Now, what this means in my game or in my code is that my rooms can load 3 different sprites, 3 different objects, if you will. So there's 1 byte that says what kind of sprite type it is. There's 1 byte, and this is the first, sprite 1. There's 1 byte that says where the X position is. There's 1 byte that says where the Y position is. So we have that for all 3 sprites. So we have 3 sprites, and all those 3 have a type and an X and Y position. So this information is also loaded when I load my room. So if I go to my room library now, here is my room library. So this is the thing we have seen before. Actually loading of the room background graphics. Loading the tiles, placing them in the right position and so on. We've seen that. But then when that's done, when we're done loading the background graphics, then there's something here. I say load A with 0000 but a 1 here. And the comment here says disable all sprites except the player sprite. This is happening when I'm loading a room. So I'm loading that, storing it to sprite enable. So basically I'm saying disable all sprites except the player. I've decided that sprite 0 is going to be the player. Disable all sprites except the player. Okay. Then we have this thing. This loop clears the sprite table values. Yeah, let's not go too deep into that right now. But the thing is that I'm clearing, I'm making sure that when I'm loading the new sprites for this room, they have a reset values. Yeah, let's not go into that right now. The point here is that I've loaded my background graphics and I've disabled the sprites, but then we get to this one, load room info. So I have also set up some zero page addresses just for this room info thing. You remember these zero page addresses, right? We use them for rows and we use them for loading rooms, stuff like that. So I also made two zero page low and high for this room info thing, so that I can create a memory address. And by the way, let's look at that right now. Here is my room info file with these room tables. Now notice that every table is called a room with a number like this. So this is the table for room 0. This is the table for room 1. This is a table for room 2, and so on. So I have all of these. So there are tons of these tables. But then we get to room 63. That's the last table because I have 64 rooms. But then we get to something down here. Room info low. Now you remember the row low table, the row high table, all those things. This is the same thing. I have a table for the low byte and a table for the high byte. What's the low byte and high byte? Well, here I say take the low byte of this memory address, room 0. So like I've said before, when we write labels like this, it's actually a memory address. Room 0 colon. This is a memory address. So here, down here, I say this is a new table, right? So in this table, room info low, the first entry here is going to be the low byte of that memory address. That's the low table. And if we take a look at the high table, the first entry here is the high byte of this memory address. So we know by combining those two, we can make a new memory address, which basically means that by combining these two, I can get this memory address. And if you remember how that worked, then we can load Y with something to get an offset. So maybe I created the memory address for room 6 now, because I had a low byte and a high byte. And then I say load Y with 0, 1, 2, 3, 4. Then I can load this thing. So this is a little complex and you have to be comfortable with that zero page thing. But hopefully you can see what's going on here, that by using these extra tables, then I can find a specific room. Now these are simple, right? Because here we can use, for example, our X register. I need the room info for room number 5. So I load X with 5. 0, 1, 2, 3, 4, 5. So then I can load this from the low byte table, and of course I need to do the same thing for the high byte table, and I store those in those zero page addresses, and then I end up with something here, room info low, and let's see, here at the beginning of my room load subroutine, I set the zero page variables up for room low, room high. We've seen that before, but I also do it for room info low, room info high. And I do all of these at the same time because all of these need to match, right? Because we are loading a room for a specific room number. So if this was room number 5, I need to load the background graphics for room number 5. So I need to find the place in memory where the background graphics are for room number 5. But I also need to set up this room info thing, so I can find that in memory as well. So I set that up here, room info low, for example. So by the time I get down here in my load room routine, then this is actually a memory address, room info low. And if this was, let's say that it was this room number 5 that we were talking about, that means that now I'm starting to load from that memory address, but comma y. So the y is now an offset. So that means that, let's see, room number 5, if y is 0, then I'm going to load this one. If y is 1, I'm going to load this one. Y is 2, only this one. So that's, as you know, how that zero page system works. And this works out okay, because if I start loading CP room info low, comma y here, yeah, we can't go too much into detail, because this can get super confusing. But I've set up y so that now I'm starting to load sprite types, which means that I'm loading this address. I'm loading this entry from this table. So I'm loading whatever is in here. Then I'm storing that in a variable called sprite type. Then I'm incrementing y, so increasing y by 1. Because now I want to load something else from that table. And since I increased y by 1, then I go down here, load the next thing from that table, which first I loaded the sprite 1 type, then I'm loading the x position. I'm storing that into sprite x. That's a variable. And I'm incrementing y again, because now I need to load the next thing from this table. That's the y position. So I'm incrementing y. I'm loading this again with a new offset here in y. And I'm storing that in the variable sprite y. So now I've loaded the x and y position and sprite type from my room info table right here. Alright, so I'm loading some other stuff here also from the room info table. But the point here is that by doing that, now I have another subroutine in a Sprite library, createSprite. Now we get back to this one. So now I have set these variables here in my room loading routine. So now I have this sprite x thing populated here. Okay, so let's go back to a Sprite library. So here in my createSprite routine that we started to look at, now this makes sense, sprite x, because we know that in my loading routine for loading rooms, now I set the sprite x, and now this even makes sense to us. We know that sprite x, that's the x position of a certain sprite. So I'm loading a with sprite x. Now, the way I've set this up is that if in my room table here, if the x position is 0 for a sprite here, then I'm not going to be loading that sprite. That's going to be the same as don't bother with this sprite. The x position is 0, so basically it's off screen. So I'm not going to load that. So I'm setting load a with sprite x, branch if not equal. That means that the x position has to be something else than 0. because if it is 0, load sprite x, branch if not equal, well, it was 0 now. Alright, then we have to go here. Jump, done, create sprite. So we're not going to create the sprite if the x position is 0. But if it's not 0, let's say 50 or whatever, the pixel position for the x position was 50, let's say that. Alright, then it's not 0, so we go down here. So we loaded sprite x position, which means we don't have to do it again. So I just store that into sprite x pos, comma x. Now there's a lot of stuff to keep track of here, but remember x now, that's the free sprite slot because of our loop here. The x here is keeping, the x in this loop is keeping track of what sprite slot was free. So the x right now is the free sprite slot for our new sprite. So that's why we can do this, store that in sprite x position for this new sprite that we're creating. And then I'll load sprite y, which we in here in the room loading routine, we got the sprite y value, so we stored that into a variable called sprite y. So we have that as well, so I'm loading that now, and I'm storing that in the table for y position for this specific sprite. Then I say load x with sprite type. Now I also got the sprite type here when I was loading the room from my room info table. So sprite type, I got that, but here it gets a little bit complicated again, because now I do the same thing with this low byte high byte thing, but this time it's a table specifically for sprite types. So here is my sprite info tables. We looked at room info, I have something called sprite info. Now this is the same concept. So here I have different tables for different sprite types. So you can see here the first table is called sprite player. Now there's let's not look at the sprite player actually, because that was just constants. Let's look at sprite monster, for example. But all of these have 1, 2, 3, 4, 5, 6, 7, 8 bytes. So they have the same the same values or same type of values. So the first entry in these tables is what kind of type they are, and then we have what kind of vertical speed they should have, what kind of horizontal speed, jump strength, what color they should be, and here we even have their edge reaction or the solid reaction, or the initial action type they should have. So each sprite types have their own tables. So let's try to make this little less complicated as we can. But the point is that I loaded sprite type here. When I was loading the room from this room info table, I got the sprite type for one of the sprites. I can have 3 sprites in this room. Now I'm just loading one sprite. Sprite type, okay, fine. And then I got to this createSprite routine, which is the one we're looking at. So here we go. Load X with that sprite type. Fine. Then we go to sprite type low. That's actually here in my sprite info file. So just like with my room info, I also have a low byte table and high byte table, where I get the low byte of whatever table. For every table, I need to make sure I have the low byte and the high byte for every table. For example, sprite player here. sprite monster, low byte, high byte. So that means that it's also important that I know that every sprite here has a certain number. So that's why I made these labels here. So sprite 0, that's the player. Sprite 1, that's a sprite monster. Sprite 2, that's a sprite, that's a coin. Sprite 3, that's a diamond. So I just defined those like that, which means that now I can load X, for example, with 2. And if I load X with 2 and load from these tables, that will be 0, 1, 2. So sprite coin, that's sprite 2, right? So if I load X and then try to load from this table, I get the sprite coin. Same for this one. So that's actually what's going on here. I'm loading from the low byte and high byte table, and I have 0 page addresses for those as well. So then I get down here, and now I'm loading from my sprite info tables. So for example, sprite monster here. So there's a lot of things to keep track of right now. But now we're loading from the sprite info tables. So I've already decided down here what table I wanted. Let's say it was the sprite monster. Alright, so now I'm loading from this table. That's what I have set up here now. Sprite type low. So this is the memory address for that specific table, comma y. Well, here I load y with 0, which means that we're starting to load from this table at the first entry here. That's when y is 0. So here this is just a constant, but it's it has don't worry about that. It's just a constant. It's just a number. And then I have the vertical speed. So first I load that first entry, store that into another table. That table is stored here in sprite tables. So in this case it was sprite flags. So that's here. Then I load the next thing because I increment y. So that means that now we are loading the next value from this table, which is this vertical speed. So I'm loading this now. That's going on here, and then I'm loading that and storing that into the table sprite vspeed, comma x. So sprite vspeed, that's this table. So as you can see, it's kind of complicated right now. There's a lot of stuff going on, and like I said before, now things are starting to connect. One thing is dependent on the other thing, and so on. So this is of course just a way that I did it here in my game, and you can make things work another way, of course. But the point is that here in our room loading routine, that's where we need to load in the different things that needs to be in that specific room. So the way I did it here was to solve it by making this room info tables. And not just that, but I also have, of course, like we saw, the sprite info tables. So that means that I can have specific types of sprites, for example here. And sprite monster, that's just a type of a sprite, or an object if you want to call it that. And of course I can have many, like we've seen. I can have 2 monsters in a room, for example, and I just have to read from this table, because this defines what a monster is in my game. A monster in my game has 8 for vertical speed, 30 for horizontal speed, it's yellow, and so on. So, like I said, this is super hard to explain because there's so much going on. But hopefully you can see the point here, that we have a room loading routine and we have this routine to sort of create a sprite. Of course, at the end of the createSprite routine, what I do is I load sprite enable memory address, or it with sprite binary, which we have seen is oh, come on, there we go. So it's this table, right? So my point is that I'm ending this createSprite routine by setting a 1 to that bit that at the start of this routine we found a 0 in this memory address. That meant that that slot was free. I do all this createSprite stuff and I end this routine by setting that bit to 1 now, because now we created a new sprite and now that slot is occupied because we just created a new sprite here. So I hope that was somewhat understandable. So this is probably something that you have to study a little while to go through all of this, try to find out how it works, but hopefully you can understand the concept. This is a way that we can load a room with certain things in there, have certain object types, or whatever you want to call it, and where we can position them, and how we can make sure that all of that happens in the room loading routine. And when we're doing this kind of stuff, it's really important that we program as effectively as possible, because like I said, we want the room loading to go fast. So I can't have a super slow routine for creating sprites here if I'm going to create 3 sprites, because that means that it's going to take a long time to load a new room. So that's also something to keep in mind, of course. Alright, well, this was probably a super complicated episode, and but I hope that you at least see the point I'm trying to get across here, that we need to make a system for creating objects, or whatever you want to call it, and we need to connect that to a room loading routine somehow. So like I said, how you do it, that's completely up to you, of course, but in that loading routine for the room, that's where we need to include some sort of sprite system. Okay, well, I hope this was, as I said, reasonably understandable. We just have a few episodes left now in this series, but when we're done with the actual game, there will be 2 more episodes. I'm gonna call them bonus episodes, that are not directly related to the game, but I'm gonna show you how to read from diskette, and we're also going to take a very quick look at how we can make bitmap graphics. But that will be at the very end of this course. Okay, well, that's it for now. Hope you got something out of this. I'll see you next time. Bye bye.